The idea behind the study was to determine whether it would be possible to define a measurable model for comparability in order to provide companies with a basis for decision making. Another decisive factor for the study was that production time can be measured and analysed, therefore we wanted to create something comparable for engineering. The concept for the study was developed jointly with the European 4.0 Transformation Centre, E4TC, who are based in Aachen, Germany. The main focus of the Institute is to take care of the practical and optimal application of software solutions, such as ERP, PDM, and also CAE, and to digitise engineering and manufacturing processes in accordance with Industry 4.0 by integrating these solutions. In the 2 years prior to the study being conducted, various analyses were carried out with over 100 customers. From these analyses, we found a common denominator. There is no method to compare results. Therefore, we surveyed typical small and medium-sized enterprises, as well as manufacturing customers in manufacturing engineering with 50 to 500 employees. And we have now created this comparability. Of those customers we surveyed, 20 of which were analysed and examined, the results proved very positive. Measuring engineering is a challenge because it involves the conceptual and design processes. In addition, the level of training and experience of the engineer and the general working conditions have a considerable influence on effort, time and quality. Therefore, direct measurability is therefore not possible. The idea of the survey was to define a model for a standard engineering process with the help of those companies which can classify and compare their actual and target situations, thus enabling evaluation and grading. With the E4TC, we have defined the grades as levels 1 to 5. We all know this grading structure from internet ratings, for example 4.5 of 5 stars. By grading in this manner, it will enable the clear presentation of results at management level. We have opted for a 3-step methodology. The user level indicates the degree and depth of utilisation of the CAE application in the organisation, as this is a prerequisite for achieving higher engineering levels. The engineering workflow describes in 8 steps the data flow, the order flow through the engineering department from the specification of the customer order to the completion of all documents required for production. In addition, there are 2 further steps in standardization: parts data maintenance and the creation of design templates, if you like, standard circuits. Each of these steps is evaluated from 1 to 5. In total, there is an overall evaluation. 1 represents manual, analog, sequential, all the way up to 5, which is representing digital, automated and integrated levels. This stands for the degree and depth of utilisation of the CAE application. It's an assessment of the level of training and the knowledge of the potential of the CAE solution and its application. Only those who know which methods exist and use them correctly can increase efficiency. An example of which is a CAE software solution have the possibilities to take in and read in the sensor actuator lists from a preliminary planning stage. If you're not familiar with this function, you cannot use the continuous data flow. This leads to duplication of work, errors and thus additional work. The seminar, The Control of the Design Area, shows how key figures can help as a control instrument, what the most important parameters are and how a suitable key figure system can be implemented on the basis of a practical example. The study shows that just 10% more effort with regards to standardization results in a 50% time saving. This is in the creation of circuit diagrams. It also highlights that you can save an additional 25% of time if you utilize partial automation in this circuit creation. The greatest leverage for all companies lies in standardization, parts data maintenance, and the creation of reusable standard circuits. The companies that proceed with this method have a considerable competitive advantage. All in all, an average increase potential of 20% can be created. Here, an analogy can be drawn to the changeover in CAE from 2D to 3D. First of all, it is about the structuring, the reuse, the modularization, the platform concept and the configuration. In my view, many companies know about this and are working on it. Often, however, though, the topic is not implemented consistently and sustainably due to the initial investment. A lot of measures are necessary. The right software alone is simply not enough. The entire process must be considered. Younger companies clearly have an advantage here. They start quite differently. For example, they immediately embrace the concept of digitization.